Okay, so we read through, and fairly soon we hit these words normal distribution, so that's a giveaway about the topic we need. We're given a mu, we're given a standard deviation. So before reading any further, we know some of the things we're going to be doing. We're going to be drawing diagrams, and we're going to be using this value of mu and sigma. Okay, but reading further, we've now know that there are packs of 12. We've got random sampling going on, and we want to work out the probability that the mean length is less than 1 meter. So we're going without further ado into a question about the mean of a random sample. Okay, so there are big clues here that this is not just a plain normal distribution question. Okay, it involves a sample mean. So we have got x, which has a normal distribution. All right, and mu equals and sigma equals, all right, but that was for individual straps. We are now looking at a sample of a number of straps, so we've got a value of n, okay, so we've got x bar, okay, is going to have we need it to have a normal distribution, okay, we've got a value of mu, which is the same as before, but now we're going to be working with the standard error. Okay, so use your formula for standard error. We've got a sigma, we've got an n, and get a value for the standard error. Okay, you can fill these in. It's nice if you do, but the important for data within we need to work with is over here. So now we need the probability of a mean length being less than 1 meter. So it is not optional to do a diagram. Okay, and the parts of the diagram that are always the same are those. Okay, that's a z-score of 0 in the middle. We also happen to know the mean score in the middle. You need to find out the value that we want to be greater than or less than, which is 1 meter. Well, we're working in millimeters higher up, so make sure you're working in millimeters, so convert. Okay, and you need to find that cutoff point of 1 meter. It'll be either here or here, and you need to shade the correct side. Okay, because what you're going to be doing, having set this up, is you're going to be having to get a z value using the formula. It's a sample mean question, so we need to use the x bar version of the formula, which has an x bar here, and we divide by the standard error. So you're going to get a z value here, and your diagram will give you a good check on whether the z value you've got, it should be positive or negative, and then you have to decide whether to use it as a lower limit or an upper limit. It's a forwards question, so we're using normal CD. Okay, and you have to decide your lower and upper limit. So are you going from minus 99999 up to something, or are you coming from something up to plus 9999? So that's why your diagram is essential. Okay, so that was part 1. Now part A. Part B, we've now got someone measuring, it's in bold, the thickness. They're taking a different measurement. So all the work we've done in part A, we can put on one side, and we're finding a random sample now of a different number. So in part B, we've got a new value of n. Okay, we've got a value of x bar. What are we trying to do? We're trying to get a 99% confidence interval. So as soon as we see that we're working out a confidence interval, we know in part B, we're going to be using the confidence interval, which is something plus or minus something times the standard error, which is something over root something. So you quote that formula, okay, and the things that you need to slot into that formula are an x bar and a sigma and an n. And the only one that needs any actual calculation from you is z. Okay, and for the z, we always draw this picture. Okay, so you have the percentage of the confidence interval, you work out how much area is hanging off each end, and you get a p-value, all right, from the table. Make sure you use a probability to the left of a cutoff, because your calculator likes the left. And you'll get a z value for that. Now, you might get a positive or negative value from your calculator. Tend to quote the positive one because that's what's on the mark scheme. Okay, but even if it's all right to find the negative one, just say you're putting in the positive z into the formula, and then substitute these 4 values in here. Get 2 answers. Make sure you present it correctly. So something comma something in square brackets, and make sure that that's the low one and that's the high one, and that will be your confidence interval. Confidence intervals ought always to be easy marks. And then we've got to comment on a specification. Now, without reading any further, we know that we tend to like to comment both on individual straps and the mean of a sample of straps. So, what's the manufacturer claiming about? Okay, the manufacturer is actually making a claim about the mean. Okay, so your first comment, and the most important comment, is going to be, do we think it's plausible that the mean actually is 4.5 millimeters? Okay, so you look and see whether that value of 4.5 is in your confidence interval, and you may even get a mark for saying whether 4.5 is or is not in your confidence interval. Okay, then you need to then actually do what you're asked to do, which is comment on the manufacturer's specification. So do we believe that the manufacturer's specification is being met or not? The manufacturer's specification is about the mean thickness of such straps. Okay, so here your comment on individual straps, which is normally that they might be more or thicker or thinner than 4.5 millimeters. You can still say that, but it's unlikely to be what's being looked for in the marks. Okay, so I hope that helps with that one.